Hi everyone. Today we're going to continue with what we started talking about for the first half of this week being streams and talk about floods. So it's a bit of a short lecture, but it's a cool one. I have a few fun videos. Maybe I shouldn't use the word fun. I have a few interesting videos to show. So what we're going to do is we're going to learn about the two different types of floods, so slow onset floods and flash floods. We'll talk about different environment types and soil types and how that impacts floods. We're going to learn about flood curves and how to read flood curves and talk about recurrence intervals and recurrence times. And then we will think about how all of this relates to the hydrologic cycle. So, if we remember, our hydrologic cycle or water cycle is how water moves from the ocean into the atmosphere to the land and vice versa. So we are still down here in this area, the stream area. So we learned about streams and rivers on the first half of this week, and now we're going to talk about what happens when there's too much water in those streams and rivers. So what is a flood? A flood is when water exceeds the volume of a stream channel. So when water flows over the banks of the stream, it is no longer contained in the stream channel. It spills out and spreads out over what we call the floodplain. So generally, floods occur, well, pretty much always, floods occur when water enters the stream or the watershed or the drainage basin faster than it can be removed. So removing water from the water basin happens either by evaporation, so evaporating back into the atmosphere, or absorption, so the ground actually absorbing water. When water is falling into the area faster than it can be removed, the water is going to accumulate. Once it gets to be too much, there will be flooding. So this happens when we have very heavy rains, when the ground is already completely saturated, so the ground can no longer absorb any more water. When we have a large amount of water entering the system very, very quickly due to snowmelt. So if there's a large amount of snow nearby, the temperature spikes and all of that snow melts at the same time. That's similar effect to very, very heavy rains. Or when we have a dam or a levee breaking. So when a huge amount of water enters in an unnaturally quick way, we will have flooding. So there's two different types of flooding, slow onset floods and flash floods. So let's go through the differences between them. Slow onset floods are sometimes called seasonal floods. These are floods that take multiple days to occur, so this would not be something like a dam breaking. And these floods can last for multiple days, even weeks. So this is generally caused by something seasonal, something that we do expect and something that we can predict, like melt in the spring. So melt of winter precip being snow and ice in the springtime, combined with and or seasonal spring rain. So when we know that there's a peak in rainfall in the spring, we can expect flooding at that time. In monsoon regions, so regions of the world that that have a monsoon climate, in the wet season of the monsoon, where we know that there's a significant amount of rainfall going to come during that season, we generally expect flooding from that extra rainfall. And another is when a storm system, like a hurricane, stalls in one location. So when a storm system gets stuck or remains stationary over one area, so it's bringing a large amount of precipitation over for an extended period of time, we will see flooding there, but it won't be as dramatic as something like a flash flood, because it's going to occur over multiple days as that storm system sits and empties precip onto that region. So what happens is the ground becomes saturated with water, so it's completely filled. It cannot absorb any more water, and all the additional water after that becomes runoff and runs off the surface it's going to flow into or try to flow into stream channels and river channels, but when those streams are already full, we will have flooding. So this can actually be used as a benefit. So slow onset floods, seasonal floods are often actually very important for ecosystems and societies because we know to expect them. We can rely on them. So some of the positive things from these floods, they can actually be really essential, specifically for farming. So a lot of farms can be nearby rivers because rivers might have seasonal flooding, and that seasonal flooding will actually bring and replenish nutrients to that farm. So specifically the Nile River in Egypt floods every year, and the farms all along the river actually rely on this flooding to bring nutrients to their crop, to bring nutrients to their soil. So when the floods are small, the floods are not as bad, it's actually a bad thing because that means not as much of the farmland has been deposited with new nutrients. So at certain rivers, they actually want large floods. They're hoping that the flood each year will be very large so that more nutrients will be brought to a wider area so that more of their farmland will be replenished with what it needs to grow good crops. So slow onset floods, they take a very long time to develop. That's why they're called slow onset. Generally, there's a large amount of time for us to prepare and evacuate. So we might know that the rain is coming. We know that, okay, the temperature is going to peak. That means all of our snow is going to melt. That means we can expect flooding. It's something that happens generally on a timeline or a time scale with which we can combat. So it's something that for the most part we can be relatively prepared for and therefore get people out of the way. So slow onset floods are not as deadly for us as the other type, which we'll get to. Sometimes they can still be just as damaging in terms of property because you're not going to move your house in time, but you and your family can get out of the neighborhood, things like that. A lot of times these floods will bring a huge amount of water. The water will last for a while. And then because the water will be standing water, so the flood, when it gets to its peak, it might be flooding your whole town. The water will be moving relatively slowly before it starts to recede. So at the peak of the flood, you'll have a maximum amount of water. You'll sort of have standing water before the water starts to recede. What that means is all of the sediment, all of the debris that's carried by that floodwater has the opportunity to drop out of the water. So these slow onset floods often leave behind a really thick layer of mud and silt. So there is a lot to clean up after these floods. So this is a precipitation map from Hurricane Harvey in 2017. So this is an example of when a hurricane stalled over a specific region. So this is Texas right here. This is the Gulf of Mexico. This is Mexico. Here's Louisiana, New Orleans down here. So you'll see that this is the maximum area of precipitation and it decreases outward. So there was a huge amount of precipitation because this hurricane just stalled here for a couple days and pounded them with rain. So there was a huge amount of flooding in Houston, and it was all slow onset flood. It wasn't something that happened immediately. It was that there was so much water over multiple days that the water didn't have anywhere to go. So something interesting is this is a NOAA figure, and the government agencies actually had to add this color, so this like almost beige-ish pink color, they had to add a color to the precipitation scale for the color bar that they use for precipitation because they had never had to show this amount of precipitation. So the highest precip used to be shown in purple. They actually had to add another bit because the precipitation was so high, higher than what our maps generally show. Fun fact. So the other type of flood is called a flash flood. So it is the kind of the opposite of a slow onset flood in that it happens incredibly quickly, and it is often very difficult or impossible to actually escape the path of the water, So this usually happens from a surprise intense rainfall or rainfall in an area that is not ready to receive that rain. In terms of the ground is something like a desert where the ground will not actually absorb any water because it's not used to it, or where the water is already, the ground is already completely saturated. So I have a video of a flash flood here. So this is a small stream that's generally by these, this office building by the parking lot. Yeah.
I'm so glad I parked at the front today. That's coming fast. Should we move our cars out the front of the building and just go? Like, it's not going to take much.
He's right. It's not going to take
look
much.
At it, it's just coming fast.
Yeah, but look at these ones down here. They're all moving.
All shifting.
Even if they came now, they still couldn't get their cars.
No. Oh, no.
You got it?
Yeah. Oh. Oh, my goodness. Don't, oh, mate,
So
don't. Just let it go.
He's taking the air out of his tyres. And as soon as you do that, it floats down. It's
smart.
2 cars.
I actually learned that from this video.
So far.
Take the air out of your tires and the car will not float down the river, so they say.
Don't. Oh.
He's taken the air out of them.
There's another one. That is unbelievable.
See if he can take his letting air out.
Oh, lucky.
Save his car.
Just. The rest of them are gone. Yeah, oh my goodness. Here you go, these ones. They're just, oh. Something must be trapping those ones.
Our cars are right at the front, aren't they?
Oh, I hope so. Oh, here's, look at that.
That's the silver one. No, it's not. It's another.
If you want to watch the rest of that and hear their fantastic reactions, the link is in the slides. So that is an example of a flash flood where the small stream by their office building clearly overflowed its banks into their parking lot. So if you get hired at a job after you're done at Saddleback, make sure you check on nearby streams in the parking lot where you park. I like to park up on the top level of the parking lot, the staff parking lot at Saddleback, so hopefully I'll be okay. Flash floods can be incredibly dangerous, as you just saw there. It was just taking cars. Thankfully, the building seemed to be up a little bit away from the stream, but that seems pretty horrible for the owners of those cars. Flash floods generally happen in very dry environments, so this is a map of flash flood hazard. You'll notice that the areas that get a normal amount or an average amount of precip, New England, most of the East Coast, specifically also the Northwest, the Pacific Northwest, and the Rockies. These are regions that have very low flash flood hazard because those areas get a lot of rainfall already, which means the ground is used to having a large amount of water. So a region like the desert, maybe down by us, in Texas somewhere where the soil does not normally absorb large amounts of water or any amounts of water. When rainfall does come, the soil cannot absorb. So it's sand, it's silty, it does not have the ability to absorb water the same way that the soil in areas that get a lot of rain do. So flash floods are much more common in areas that generally don't get rainfall and then get a storm. So it's usually dry environments that do have a surprise storm. So this doesn't usually happen with a small sprinkle. This would be some sort of real storm that occurs that brings a good amount of water and precipitation to these areas. Generally, there is not a lot of warning time. So like that video we saw, if there had been some warning time, if people had known, this river by our parking lot is going to flood, hopefully everyone would have moved their cars. So like you saw, there was not a lot of warning time there. So it can come as a bit of a big surprise. Another interesting aspect is that if it rains in one area of your drainage basin, doesn't mean it's raining everywhere. So that doesn't mean it's raining downstream. So it can rain up near maybe the headwaters of the drainage basin, but all of that water that happens all at the same time at really high rates is going to flow down the river at the same, to a different location, bringing that flood to regions that didn't necessarily get any rainfall at all. So if there's rainfall upstream of your drainage basin, you have to be aware that if you are downstream of that, you might experience the flash flood without ever seeing any rain yourself. So I have another video. This is the last video of the day to show you that. It's a pretty cool one. It's a little long. I won't show everything, but it's pretty interesting. So this is in southern Utah.
We're standing here at the confluence of three washes. The one over here to my left behind me in the video is Coyote Wash, and it's a pretty decent sized drainage area. The one in front of me, which I'm standing in, is much larger. Coyote is just a tributary to it, and it's called Wahweap Wash, and it's a huge drainage basin. This thing delivers some massive flash floods when we get heavy rains north of here. And behind the camera, if you turn around, directly behind me here is Nipple Wash, which is also a fairly large wash. All three of them just got hit with rain, so we're gonna wait and see which one flash floods first. Little disclaimer, what I'm doing is dangerous. I have a lot of experience with this. I know these washes very well. I know where they start, I know where the headwaters are. I know how to judge the size of a flood when I first see it, and then I can act accordingly to make sure I don't endanger myself. I don't recommend doing this unless you're, really familiar with what you're messing with, because these things can't kill you.
So this region where we are looking at never received any rain. This is all rain coming from upstream of these streams. So notice it's not clear rainwater. This is bringing all sorts of debris, even what looks like a large tree branch, downstream. Everything picked up by that water is coming now to this area, which didn't receive any rain at all. That's a lot of debris. Notice all this is silty, muddy down here, which must have been deposited from the last time that this happened. I'm sure another layer of silt and mud will be deposited once this water flows away. Completely overtakes the vegetation that had started to grow. So it occurs very, very quickly. A large amount of water hits this area very, very quickly. Imagine finding this nice, empty, flat land. It's nice and sunny. While you decide to set up camp, you're going to camp there overnight, and then all of a sudden you're hit with this, this flash flood. Would be horrible. So always be aware of the flood potential and the nearby precipitation. If there's a storm somewhere upstream, you can bet that water is going to be come down towards you pretty soon. So flash floods generally occur in deserts, like I said earlier, where the soil and the ground is not able to absorb any water, or in very heavily urbanized areas where the ground is covered in pavement and roads and parking lots and sidewalks and buildings, so there is not a lot of soil to absorb water. So it can happen also in moist environments if the soil is too saturated. So flash floods can occur in areas that generally get a lot of rain if the soil is already at max capacity. So if it's already completely saturated, it can't absorb any more water, and then they get another storm, all of that water will run off on the surface into the stream channels and then overflow the banks. So let me go to the next slide. Yeah, so let's talk about hydrographs. So now that we know the types of the types of flooding events, we can talk about actually measuring and predicting floods. So we use hydrographs, which show the amount of water in the stream, the time, and the precipitation generally. And hydrographs are for one location. So you might have multiple hydrographs down your stream. So you can make a hydrograph for at the top of your stream, in the middle of your stream, at the bottom of your stream, and they'll look a little different, but they'll all have the same components. So the amount of water in the stream is shown by your discharge, and you'll see generally a peak when you have a flood, which is a peak in water in your stream, of course, will be the highest part of the flood. Usually time will be on the x-axis, so as you move through time, you see the water in the flood. If we follow the purple line, the water in the stream increases. Then also precipitation is usually graphed here as well. So you can see here was our peak rainfall. So these orange bars correspond to the precipitation here on the second y-axis. So after our high precipitation, we see that there's a peak discharge or a peak amount of water in your stream a little while later. So the peak stream discharge does not occur directly as the rain falls, because all of that rainfall in your river basin has to flow into the stream. So it takes some time for all of the rain that fell to accumulate in the stream. So we call this the lag time. So the lag time is the time between the peak rainfall and the peak discharge in your stream, the peak of your flood. So depending on where this location is, the lag time will change. And also the shape of your curve can also change. So with a flash flood, you would expect a shorter lag time, because the flash floods happen very quickly. and also a steeper curve. So you would expect the lag time to be shorter, and then the curve on the way up to be much steeper. Also on the way down it can be much steeper too, because this mass of water occurs quickly and it moves quickly. It moves away quickly. So what are the other things that could affect the way that this graph looks, the way that the hydrograph actually appears when we graph it this way? The type of rock. So the type of rock or the type of soil would affect how the stream floods. So is that rock is water easily absorbed into that soil? Does water immediately run off the rock? Vegetation. So if there's a lot of vegetation nearby, you're actually going to increase your lag time. You might even decrease the severity of your flood because that vegetation is going to absorb a lot of water. So the presence of vegetation is generally very good for preventing damage at a flood. Previous rainfall. So has there been rainfall lately? Is the ground already saturated? Is the ground completely dry? Is the ground somewhere in the middle? That would probably be the best, meaning that the soil can absorb more water, but also is used to absorbing water. And then the drainage basin shape. So how does the drainage basin work? Do you have all of the tributaries, all of the water hit the drainage basin at the same time? Or are there many small streams that bring water into the main stream? So these different things can actually influence how the flood appears downstream. The last one would be urbanization. So are there parking lots, are there sidewalks, are there towns nearby? That is going to cause your flood to be more like a flash flood and more of a dangerous flash flood because water will just run off on top of the asphalt, on top of the pavement, instead of absorbing into what could be soil underneath. So flash floods, they can be very dangerous for us. Most of the deaths that occur during flash floods are actually in cars. So I wanted to show this. This image shows water that's 30 centimeters deep. So 30 centimeters deep will have a strong lateral force. There's going to be a strong force moving your car like we saw in that video of the flash flood. This would be extremely dangerous. 30 centimeters. 60 centimeters, this one would be horrible. At this point, not only will your car be moved downstream, but it will actually start to float. So there's enough water that your car will start to float because of the tires. So this would be generally a fatal incident. Another is when you're driving in a large amount of water, specifically if that water is muddy or dirty or silty where you can't see through it, you might not know what the road looks like beneath. So if there's a large amount of water flowing, and if it's flowing fast, you can expect that there's a large amount of erosion. So this is a really big problem with flooding on roads, is that the flooding might actually wash out some of the road, but cars will drive through it not realizing that the road is washed out because they can't see it. So that can be very, very bad. In summary, do not drive through moving water, ever. Very bad. So when we look at floods and predicting floods, what we do is we look at flood frequency and also what we call the recurrence interval. So the risk of a flood is generally considered, or we consider annual probabilities. So how likely is it that this year we will see a flood of some size? So the recurrence interval is the average number of years between floods of a certain size. So if you have a huge flood, how often does that occur statistically? So a very severe flood might happen much less often, well, will happen much less often than a very, very small, insignificant flood. So a flood with a high recurrence interval generally means that there's a lot of years in between. We are going to expect that the probability of that flood to be, the probability of that flood occurring to be less annually. So you can see this figure here. We have the probability of what we call a 2-year flood, which means statistically a flood of this size, where's my mouse? This size outlined by this dotted line occurs once every 2 years. So every other year, this stream sees a flood that extends this wide. Oops. However, every 100 years, they see a very, very severe flood that extends all the way up to this dotted line here. So that will have a lower probability of occurring. It only occurs about once every 100 years, statistically. So when you are building a house, building a city, building a farm, you want to look at the frequency and the magnitude of the floods. So we look at past data to determine these recurrence intervals, to determine the probability of a flood occurring of a certain size. So we look at, well, how many times in the past 100 years, in the past 50 years, in the past 1,000 years have we seen a flood of this size? So for example, there is a 1 in 2 chance of a 2-year flood this year. So that would be this flood here. It happens statistically every other year, so there's a 50% probability of this flood occurring, 1 over 2. A larger flood, which we would call a 10-year flood, which means it only occurs about once every 10 years, we would say there's a 1 in 10 chance of this flood occurring this year, which would be a 10% chance. So there's a 10% chance of this flood, a 10-year flood, happening this year. So if I said that the recurrence interval of a flood is 20 years, that means that the probability of that flood happening next year is 5%, because 1 out of 20. So 1 out of 20 years recurrence interval is 5%. So the probability every single year, there's a 5% probability that a flood of this size will occur. So another important thing to talk about is urbanization. So us, what are we doing to stream environments? So this is flooding from Hurricane Harvey, which I showed earlier with that precipitation map. So this is in Houston, Texas. This is, whoa. You can see these people in a boat on the highway. Huge amount of water. It was a very, very, very bad flood. So when we look at a hydrograph of an urbanized area before development and then after development, we can see how the hydrograph would change. So here we have time on the bottom x-axis, here's stream discharge on the y. So pre-development, meaning before the city was built, let's say, a flood might occur, there'd be a larger lag time, so the increase in water in the stream would happen later, and it would also be a more gradual increase. So the peak of the peak of the flood will not be as high, and it will happen more gradually. So the peak is low, and the slope is relatively low on both sides. However, once we have an urbanized area, we have our city, we have our buildings and our parking lots and our roads, that water that falls in, let's say it's the same storm that causes this flood, the water that falls is not being absorbed by the ground as it used to. It's now running off along the surface of the roads and the parking lots. So there's no soil to absorb that water. That water is going to hit the streams much faster, because now it's not moving through the soil, it's actually just running off along the surface of the pavement. So the flood starts earlier, and the flood is going to be much worse. So no water is being absorbed. There's going to be more water in the flood, and the increase happens very, very, very quickly. So this would be something like a flash flood, where you would expect a very quick increase of discharge in your stream. So your stream all of a sudden has a huge amount of water, and that large amount of water will pretty quickly move downstream. So if we were looking at this hydrograph at a location a little bit downstream of this, we would see something similar, but the peak would occur a little bit later. Because first the peak is in one location, and then it will actually move downstream. So the flood moves downstream together. So can we control flooding at all? What can we do to try and help preserve the land and the towns and the cities from flooding? One option is artificial levees. So that's this GIF over here. You can see here's our sea level, and here is a bit of a hill along the sea level built in between the ocean and the houses. If you build that up, you create what we call an artificial levee. You can actually block the water from going into these yards. So we can try and take these preventative measures, knowing there's a possibility of this sea level rising, of when there's a flood or when there's a storm, this water level is going to rise. We can try and block it by making something like an artificial levee. Another thing to do would be plant vegetation. So as I said, vegetation is going to absorb a lot of water out of the soil, and pretty quickly. So vegetation helps delay the onset of a flood by absorbing a lot of water. So to prepare for a flood, really, the only thing that you can do personally is to be aware of your area. So be aware of the flood hazard. Be aware of recurrence intervals. Look at a flood hazard map. Know if flooding has happened in the past in your area, so that you can be prepared, or you can understand what might happen again. So here's a flood hazard map of California, and it's nice because it separates different colors. So alluvial fan flooding, we know alluvial fans are the streams that come down off of the mountains and then deposit all of the sediment in that fan shape at the bottom of the mountain. So alluvial fan flooding would be water rushing down the mountain and then flooding that area. That would be the orange. Also, river flooding, you can see in the pink, is generally located all around different rivers, as you'd expect. And then also coastal flooding. So if you'll notice, all of Southern California has a thin bar of that purple color there, because there is high coastal flooding in probability, because we don't have, maybe not so much in Laguna Beach, but everywhere else where we don't have high cliffs along the beach, we can see coastal flooding. So here I have some California maps in terms of this one on the left shows the value of all of the structures that are built in floodplains. So built in an area prone for flooding. We are the worst down here in southern coastal California, with $230 billion worth of structures built in flood-prone areas. And then the next one on the right just shows population. So how many people live in flood-prone areas. We have us with over 3 million, and also the Bay Area, so San Francisco area, with over 1 million people in flood-prone areas. So when we think of flooding, we generally want to think to the future. Well, what's the risk going to be like? I'm going to buy a house. Should I buy it here? Should I buy it there? How will my insurance change? With the future of flooding, we being climate scientists are expecting flooding to actually get worse because of climate change, because of global warming. So global warming is doing a couple things when we think about the effect on flooding, in that there's going to be there are warmer temperatures, which allow for more precipitation, so there's more evaporation, and then more water in our atmosphere. So we know that precipitation is going to become more extreme with future global warming, future climate warming. This means that we're not going to see necessarily an increase in the number of storms, but an increase in the intensity of storms. So generally what we're finding is that dry gets drier, wet gets wetter. So more dry areas are going to be even more dry, but the storms that they do see will be more intense. So that means that the flash flooding will most likely be getting more and more intense in the future. We also know that with warmer temperatures, we're expecting less snow and more rain, specifically in wintertime and also on the mountains. So instead of getting snow, which will fall and then stay on the surface, it doesn't hopefully melt right away. It will stay as snow up in the mountains. It will stay as snow on the surface and then slowly melt in the springtime. We're expecting actually more rainfall, which will immediately flow from the location downstream. So that will increase the water flowing in the stream channels, and that will increase flash flooding as well, specifically those alluvial fan floods that we expect at the base of mountains. And then we know that sea level is rising, so continued sea level rise means there's more water closer to everything that's built along the coasts. More water just increases the risk of flooding along the coasts. So in the future, we are absolutely expecting floods to be getting worse and more extreme and more deadly and more costly. So if you are looking for a home right now, I would say please definitely check the flood risk before buying your house. So this can be flooding can be very, very difficult to get covered by insurance. So if you were to buy a house, please make sure that you check the flood risk. So are you buying a house that's within the 2-year flood zone? You're not going to get any insurance. If you are buying a house that's maybe within the 1,000-year flood zone, you'll have a better chance. So beware, that can be very dangerous to buy waterfront property or nearby water property, not just coasts, but rivers. Rivers actually probably are worse. So make sure you check your flood risk before you buy a house. And I wanted to show some real footage from what we call the California superstorms. So California superstorms are where we have massive flooding in California. The last real occurrence of this, where it was as bad as it's been, was in the 1860s. These floods are thought to occur every 150 to 400 years, so they haven't occurred that often for us to have a more specific date. But California has seen some horrible flooding across the state due to increased rainfall in one season or 1 month usually. We see a massive amount of rainfall that occurs all at once to the point where the streams are overflown, the ground cannot absorb any more water, and the water runs off, flooding everything it touches. So my last slide, some human impacts, so the ways that we are actually affecting rivers and flooding. A lot of it is just urbanization, so building towns, building cities, building streets and parking lots without thinking about where is water going to go can be very, very dangerous, especially in regions that are not used to getting a lot of rainfall, and agriculture as well. So if you take a dry area, start pumping water with for farming, you're really changing the way that that area will react to flooding. Water overuse is another. So if we are using a huge amount of water, there's going to be less water in the soil, less water available. And dam construction. So of course, building dams means that you're flooding one area and then limiting the water that flows to another area. So that can be a big issue as well, environmentally, and then for how that river, that stream channel reacts to flooding in the future. But we really do depend on streams, so we need streams, even though sometimes they flood. We need them. We need them for water, for irrigation, energy, definitely, and then also transport. So streams and rivers are used a lot for transporting goods, transporting people. So we really do rely on freshwater streams.